So this is a design pattern that maybe not everybody's seen when they build an application, and I'm assuming if you build something relatively small, this is out of scope, or if there's no true dependencies and workflow embedded in it. But let's say you're doing a U.S. income tax application, or you were doing a large insurance application of some type, a regulatory application where the answers that you give may drive entirely other workflows. And I've seen this with loan processing also. So the idea is that we're going to task drive the work that needs to be in an application, and that we want to reduce the coupling that's involved by reducing, I'm on page 3 and I know that page 5 is needed if I do this. No. It's not the user interface that we drive, it's the work that needs to be done, and the user interface happens to sit on top of the work pattern. And that's another talk. Anyway, so we're going to reduce the coupling with directed graphs, and these could be cyclic or acyclic. And at the end, I'm going to talk a little bit about how we did this in an application where we didn't use a single graph, but we used a set of loosely coupled graphs, each which described its own section. So in a sample work stream here, we've got we gather some information about people. Let's pretend this is a U.S. tax application, because a lot of people will understand that unless you don't live in the U.S., which is most of the world. So pick your own thing. Basically, we're going to describe the people that are involved in an operation. If this was a business standing up, these would be the primaries. And so we have a primary here, and then we have 2 dependents, and we're going to gather data about each of those dependents. And then there's going to be a summary section. In a large application, there would actually be more of these, right? Like if you were doing U.S. income tax, there would be income streams would be another one of these, and deductions and other things would be other parts of this. So one of the things we want to be able to do is we want to be able to support the ability to jump back, fix something, and then if that didn't change anything, we skip back forward to where we left off, right? So we gather information about that we have 3 people tied to this process, and we have a primary and 2 dependents. We go through the primary, we go through dependent 1, and we're like, man, I didn't put the right information about one of those dependents, dependent 2 maybe, or maybe I needed to fix something on the primary, so I jumped back to the primary and fixed it. That didn't affect dependent 2. So what I'd like to do is skip all the dependent 1 stuff, because that's really annoying when you get at the end of a 47 application page and you change something. And it might be if you do multiple sections like the U.S. income tax thing, you might be directed inside of that flow. Like we may or may not have people do jump around navigation on the primary here between demographic and the 92 other pages. But the idea here is we want to pick up what happened. So what we're going to do is we're going to create a graph. We're going to drive the user through the graph. We're going to lit tasks. We're going to determine which parts of the graph need to be exercised. And we're going to use rules to create lists of work to be done for those tasks. And we're going to go into or skip nodes based on those tasks. But basically, we're going to explicitly embed a workflow. And I've worked in a bunch of systems where people are like, oh, that workflow thing is too complicated. And then we wrote a million business rules and had all this crazy testing to do to figure out how to make it work. So in this case, what we're going to do is we're going to task drive. And so when we come into the system, basically there are 3 tasks that need to be done. We need to do the people task, the primary person task, because there's always a primary. If there's no primary, there's no reason to do this, because there's no taxes, no claim, no loan. The person and the person, they enter data in the people page, and it tells us that there's actually 3 people associated with this. So as we leave this, the people task has gotten popped off the stack. We end up with a primary and a P1, a dependent 1, a dependent 2, and a summary page. And that drops us immediately into the primary. And then when we're done with the primary, all we have left is person 1, person 2, and the summary to do. When we get dependent, and so the idea here, you can see that and then we go through summary. We've got no task to do, and then we know that we're done, right? So this is super straightforward. Basically, at the end of each of these stages, you push whatever tasks you know about. So the only coupling is you got to know, hey, we did some work in here, it means this task. Now, it could be that multiple stages say that you need to capture stuff about dependent 2. That's fine, because the D2, P2 in this case, P2, D2 will only be pushed 1 time, right? So no matter how many times people push it, it's no big deal. And if a rule says it needs to be removed, you're fine. So this would be the task flow, and you can see the tasks actually get pushed onto a task stack here, and then they get removed as they're executed. And the reason this works well for the backup, right? So we're sitting in primary, above the primary, and we have person 1, person 2, and summary. We go through the primary, so primary is done. And then by the time we get down to P2 and summary, right? Because we're going into the dependent 2, we haven't completed it yet. So, right, the dependent 2, even though we're in the middle of dependent 2, it's not done. It's only going to be removed when it's done. We decide to jump back to the primary. That leaves P2 and summary in the stack. What'll actually happen in this case, the way this one's drawn up, is when the user exits the primary, there's no P1 task, so there's no dependent 1. It'll automatically jump down to P2, dependent 2, because that's what's still on top of the stack, right? So we back up into the primary and deliberately, and maybe it's a manual injection here of a primary task. I didn't really draw that. And then we'll end up with P2 in summary, and then when we're done with dependent 2, we'll end up with just summary, and we'll complete the program. Right. So the tasks automatically take us back where we need to do. So basically the tasks do push and pop. There are business rules that continually reevaluate what tasks need to be added, and that can be a general set of rules, not in each subsection. And some rules may remove tasks, right? I no longer have a second dependent, so there's no reason to go through D2, right? Person 2. And the rule sets may be global or scoped. I've seen it both ways. But basically, you remove the navigation rules, right? Or you remove the data collection macro rules from the detail rules. And whenever tasks are removed if they're completed, and they can be picked up or again or restarted if they're incomplete. And we saw that in the example I did before. If you basically jump from the person 2 back to the primary and person 2 wasn't complete, we'll just pick up again back in person 2. So what about removing pieces? What if I actually jumped back into the primary and I removed a dependent and I actually had that as a task? It turns out that's actually something that's pretty easy to do. If we go back to the person task, right, in that flow that I had shown before where we backed up, we would remove person 2 at people, and it would know, hey, I've removed this person. What tasks are tied to adding a person? Oh, that person's no longer added. We'll just drop the P2, and the flow will auto heal itself, right? Like in this case, even if we didn't do backup, right? In people, I said I need 2 dependents in the primary, and then and then I'm like, oh shit, you know what? I'm sorry. Then I said, oh, I don't need the second one. That would remove P2, and the dependent 2 section would just be skipped automatically, right? So this, in some ways, can be self-healing. One of the debates is whether you have a data graph that needs to be cleaned up, but we can talk about that another time if people are interested. So what about really big graphs? I mean, I think really big. Like I worked on one we had like hundreds of pages, right? Or modules. Well, we had like 50. And what would the rules look like if you were going to like write this thing and figure out what you needed to do, right? You end up having to build a structure for something like this. And then what if we allow cycles? So this one shows it as a tree, but it's possible that we could come out, like we might decide up here in this graph, you enter something that says this graph at the bottom is required, or that this second graph is required. And let's say you skip it and you come down here to one of these others, but there's a page down in here that is like, are you really sure you didn't, take out a bank loan for blah, blah, blah? And if you say yes, it's going to pop a back task up here, and we'll come back and pick that up. So we always have the opportunities, right? We might actually end up tasking popping back higher level in the graph. And this is not purely a DAG. The reason I said that was because user choices might actually push us back into another part of the graph. So it's not necessarily an acyclic, it's the A here, the acyclic graph. We actually could have cycles in the business process, even if the graph doesn't show it. And I was going to make this a lot bigger, but you know what? After a while, you get tired of adding boxes to this thing. So one way to do this, so that before I just talked about, hey, we can do this with this task-driven thing. And I think it's pretty cool. I've actually seen it where we embedded a workflow engine or we built something. Another way to do this, instead of having that monster flow, right? Like, that was dumb. Instead of having this monster flow, what we're going to do is we're going to break this apart. And we're going to make each of the major modules be their own workflow. They all could be coded in a different language, different something, different team. And what we'd end up with is a large dispatcher at the top. And so the primary task would actually determine which workflows we're going to invoke. It wouldn't necessarily navigate you into the same flow. So in this case, we actually didn't have a workflow at the top. We just had a dispatch loop. And all the dispatch loop did was it knew which task invoked which workflows. And then we moved through those workflows as standalone mini apps. And then if they navigated out, we ended up popping back to the dispatcher. So the tasks would start flows and the tasks would drive which flows we needed to do. So I really like this. One of these I worked on, we had like 20 of these disconnected graphs rather than one large graph with 20 subgraphs in it. I mean, you can think of them as logical subgraphs. So rules and automatic processes, basically continual reevaluation of what tasks need to be done. Some rules may remove the task, like I said before. Individuals an individual may no longer be a dependent. So in that case, we might have removed P2, right? Dependent 2. And some rules, and that's some rules may remove tasks. Why did I put that in there twice? I'm going to fix this up before I post it. And then tasks are removed as they are completed. And open tasks automatically end up restarting at the top if they're incomplete, right? Because we'll flow out of a previous flow. That task will still be open. We'll drop back into that flow. And then it's up to that flow to decide whether to pick up where it left off or whether it would start over again. In a lot of cases, you start over again in the beginning and then you figure out how to optimize it. So conclusion, you can reduce coupling by segregating the navigation rules that describe the next steps from the field data and business process rules. And that's it. Have a great day.